Let's now begin our investigation of the dynamics of the logistic map. So the map is xn plus 1 is equal to a xn 1 minus xn. And the recipe for understanding a dynamical behavior is just the same as what we used for a continuous dynamical system. First, we find the fixed points. 2 is we find the local flows near fixed points. But in the case of a discrete map, we don't have continuous flow. What I mean here by local flow in this context is the iterates of the function. That is, we start near a fixed point, we start with some value xn, we then apply the function to get f xn plus 1, then xn plus 2. Those are the iterates, and we study how the iterates move when we're near a fixed point. And finally, 3 is that we infer the global flow. So as mentioned here with the iterates, what we're doing is that we start with x naught, then we find x1, which is equal to a x0, 1 minus x0, then x2 is equal to a x1, 1 minus x1, x3 is equal to a x2, 1 minus x2, ... And we just continue this and then try and infer the dynamical behavior. So let's look at the behavior in two simple cases. So let's plot as a function of xn plus 1. And let's first consider the case where a, the control parameter, is less than 1. So the map xn plus 1 equals a xn 1 minus xn is an upside down parabola whose slope at the origin is less than 1. So our function might look something like that. And now let's examine what happens when we start with a particular value. Let's start, say, with x naught over here. And let's see what happens when we iterate the function. So to get x1, we have to compute the height of this curve above x naught. So that's here. So we go up to here. So this gives us x1. And now to plug it back into the function, we want to put this x1 back on the x-axis. And the simplest way to do that is to just project, or to just extend this line all the way to the 45-degree line where the x-axis equals the y-axis, and so we have now inferred what x1 is. And so now starting at x1, we go to the function itself, and then to get x2, we go to the 45-degree line, and we get x2, and you can see that what's happening here is we follow a path, a zigzag path that takes us quickly to the origin. So in this particular case, xn goes to 0. On the other hand, if a is larger than 1, and we're plotting again xn plus 1 versus xn. So starting at x naught, we compute f of x naught, and that gives us x1. And now to figure out what is x2, we project x1 onto the 45-degree line to figure out the new starting point for the iteration of the function. So starting at x1, we will get f of x1, which gives us x2, and then we project that back onto the x-axis to get f of x2, and then we continue iterating ad infinitum. And in this particular case, we will iterate to f of xn going to infinity going to 0.